Okay, welcome everybody to the first online brown bag that we have done for Cloud Native Portland. This is, out of the goal of continuing with our content, even though we can't meet up in person right now. This is an official meetup of the Cloud Native Computing Foundation, and as such, we are subject to the code of conduct of the Cloud Native Computing Foundation. So please don't do anything really mean that would be a violation of that. Today we have with us as a guest one of my coworkers, Dan Walsh. I've been wanting to actually do a presentation myself on Podman for a while, both because Podman is awesome, also because we kind of need more presentations on desktop tools in our meetup. And since we're doing this online, I have the opportunity to have Dan dial in from Boston to actually share this in person and demonstrate Podman for all of you, which makes for an awesome thing. Dan, when do you want to take questions?
Anytime they want to ask.
Okay.
I'm fine. This can be fairly interactive. It's basically going to be a presentation and some demonstrations, and then afterwards, if we want to talk, or I can tell you about some cool features, things like that are coming along the way with Podman.
Okay, cool. So everybody, feel free to speak up and ask a question as we go along. If you don't want to speak up for whatever reason, like for background noise or whatever reason, then feel free to ask your question in the chat and I will repeat it for Dan to answer. And also feel free to use the chat for back channel talk. This is, after all, a Portland meetup, and if people want to chat about other things, that's what it's there for. So with that, Dan Walsh, who is our SE Linux guru and our head of container tools, is going to explain Podman to you and why you don't need the Docker daemon anymore.
Okay, well, thanks for having me. So as Josh said, my name is Dan Walsh. I lead the container team. My title is I'm a senior distinguished engineer, which I always tell people that means I'm a really old engineer. But basically, we've started several years ago working on container technologies. We worked heavily with the upstream Docker project and eventually decided we wanted to look at doing containers in a new way. And so we created a project called Podman. It's actually part of what we call the libpod project. For those that don't know, pods is a term that was made up in Kubernetes world, and a pod is one or more containers running in the same group of namespaces. So hopefully everybody that's listening understands at least a little bit about what Docker is and what containers are, because I'm not going to go that deep into it, but you'll see some of the technology going on. So let's see if everything works here. I think this is the right screen. Can everybody see my desk? Oh, yeah. Can everybody see the replacing Podman screen?
Yep. Okay.
So basic idea is we wanted to take advantage and see if we could replace Docker and do containers in a new way. So this is the steps if you want to replace Docker with Podman. The first thing you would do is DNF install Podman, or yum install Podman, or apt-get Podman, or even on Macs available as brew install Podman. And then you would do alias Docker equals Podman, and any questions. So that's how I like to start the presentation, but let's go a little bit deeper. So basically back in 2018, Podman's been around for about 3 years. Someone tweeted out that I completely forgot that about 2 months ago I set up an alias of Docker equals Podman, and he said it's been a big dream. One of my slogans is no big fat demons. Down below you'll see someone said, so what reminded you that you were using Podman instead of Docker? And he said he did Docker help. And when you do Docker help, it comes up and says, here's the Podman help. So at this point, I usually, when I'm presenting in front of a bunch of people, I make everybody stand and repeat after me these slogans. But it's kind of hard with this, but you guys could read it out loud. So please read out loud any text that is in red. And so you're going to say, anybody have
I
guts?
promise.
I promise to say make a copy rather than make a Xerox.
I
I promise
to
to
say
say tissue rather than
rather than
Kleenex.
I promise
I promise
to
say container registries rather than Docker registries.
I promise
I promise
to say
to say container images rather than Docker
images. I
I
promise
promise
to say containers or
to say
OCI
containers
containers.
or OCI containers rather than Docker containers.
And then so I didn't make you stand up, but I still made it. And you don't have to say Dan Quixote, but basically I've been on containers is really a Linux concept. Docker is a tool for launching Linux containers. And a lot of people come up to me and say, hey, can I run Podman containers on Mac? And can I run Docker containers on Mac, or can I run containers on Mac? And the answer is really no, you can't, because you're running containers or Linux things, right? It's a Linux thing. There is a Windows container thing, but in a lot of ways, Windows containers are quite a bit different than Linux containers. But Linux containers are just standard processes running on a system. After you might use a tool like Docker to launch the container, but once the processes are started, really at that point, the Docker engine or Podman or any of these other tools are all out of the way, and really they're just Linux processes running on a Linux system. So the problem is that people have treat Docker like Kleenex or Xerox, where they use the term interchangeably. But really what I want to get people to understand is that containers were developed in Linux actually a long time before Docker even existed. What Docker did, which was great, was to standardize two things. They standardized the image format. So when we talk about a container image, right? When I say, when you say I want to run the Fedora container, or I want to run the Nginx container, what does that mean? And what that means in container world is that most people are talking about something that exists at Docker.io or at some kind of container registry like Quay.io. And what these are is a container image. So giving you a little history here, back many years ago before Red Hat acquired CoreOS, everybody was using the Docker image, right? All these images that sat at Docker.io. Let me explain quickly what a container image is. A container image is the first thing you do is you create a directory on your system, and you put some content in it that looks a lot like root on an operating system, right? It looks like /user /etc /var. So you put all this content in this directory, and in the container world, we call that a rootfs. So you put that into a directory, any of the content and the executables that you want to run in a thing that sort of looks like, slash of a Linux operating system. And then we tar that up into a tarball. The next thing we do is we create this JSON file, which is basically defines what's in the tarball. So the JSON file has fields in it like what environmental variables do you want to run? What is the executable that you're going to execute? What's the command you're going to execute when you run your container? What are some labels? Who created the container? So there's sort of a JSON file that describes the content of the container. And when I take that now I tar both the tarball up and the JSON file, I put them together and I move them to a web service. And that web service then is really that's what a container registry is. It's just a web service that has these tarballs on it. So when Docker first invented the concept of a container image, they defined what the fields inside of that JSON file were. So when CoreOS came along, CoreOS didn't like the idea of a single entity controlling sort of the format of the container image. And if you want a little history why that's a bad idea to have a single company controlling that, all you have to do is look at Microsoft and what Microsoft did over the years with the .doc format. So remember back in the 1990s, every time there was a new release of Microsoft Office, they changed the .doc format and forced everybody in the world to update their tools. So and all of a sudden, if you were running Windows 95, you could no longer look at documents that were produced on Windows 97 or Windows 98. And so you really didn't want one company controlling the format of the what is in a container image, as everybody started to use those. So what CoreOS wanted to do is they wanted to set a standard, and they came out with what was called the AppC spec, the Application Container Specification. The problem was the AppC spec was actually different, so that the fields in the JSON file was slightly different than the fields that Docker had done. So suddenly, instead of having just one way of shipping these container images, we had two ways. And if you go back in the history of Linux, Linux has always been handicapped by the fact that there were two different ways of shipping software. So traditionally in Linux, we shipped software in the form of RPMs, and Ubuntu and Debian shipped in the Deb format. And so that anybody that wanted to package software for Linux always had to package it two different ways. When Container Revolution started, all of a sudden we had a way of packaging software to run on any Linux platform. And then all of a sudden CoreOS comes along, and they basically, forked the community, came up with this separate way of doing it. So at that point, all the leading companies in the container world, including Red Hat and at that time IBM and Microsoft and Docker, CoreOS, and a few others got together and this has created a standards body. And that standards body is called the OCI, Open Container Initiative. And they standardized on the OCI image bundle format. So now there's a standard, that's why I call them OCI containers. So if the OCI container images sit at container registry. So we have a standard now that definitely defines, sits at all the container registries, and that's the OCI format. I often like to, because I'm a member of the OCI, they gave me this jacket, and a year ago I was at back when we could go to restaurants, I was at a restaurant and someone asked me if OCI stood for Open Containers of Alcohol. And I just had to defend people at that point. No, this is a very different concept. But basically OCI allowed us to sort of standardize on those image formats. So the next thing, if you want to run a container on the system, you need to do is you need to be able to pull the container image to your host, right? So you need to get it off of the container registry and get it to your host. And so a little history on this, we many years ago opened up a request with upstream Docker to basically, if you look at these images that sit at container registries, they started to grow in size. As a matter of fact, some of these images can get to multiple terabytes. And oftentimes you want to pull down, you want to basically just look at the JSON file associated with the image to look at the fields in it and say, is this really the container I want to run? So if you ask someone, how would you, examine that JSON file associated with the container image, you would basically say you have to pull the entire image to your host, look at the JSON, and then you could do a Docker inspect. So we wanted to do a Docker inspect -- remote where we would just download the JSON file. At that time, the upstream Docker community didn't want to basically complicate that command line anymore. So they said that they'd rather us just go off and do it yourself. And they explained to us at the time that these are just things sitting in a web service. You can just go to the web server and download the JSON file, right? It's sitting at a web service. So we built a tool called Scopio. And what Scopio was is just basically, originally was just a tool for going out and grabbing that JSON file and allowing users to look at it. Eventually Scopio grew into a much more powerful tool that allows you to copy images from any container registry to any other container registry, or from a container registry to your host, and different types of storage. And that now basically Scopio is a great tool for moving container images between different types of container storage. So either to other container registries, it's a local machine, you can copy right into the Docker daemon if you want, or you can copy into storage that we'll use with Podman. But at the time we were working with CoreOS and we wanted them to embed it, and they didn't want to execute a command. So they asked us to break Scopio into two different tools, to basically break it into a library and then a command line tool. And so we did that, and we created what's called GitHub Containers Image. So now there's a Go library that has all the protocols required to move container images from container registries to the local host. So basically all the protocol that you would expect from, say, Docker push and Docker pull. So that's what container image. So now we have a way of identifying what a container image is at a remote machine, at a container registry. We have a way of pulling the image to the local host. The next thing you need to do is you need to take that tarball and explode it on disk. Well, I sort of oversimplified what a container image is, in that I really explained sort of just one layer of the image. So I create that directory, I basically put stuff in it that looks like root, and then I tar it up and I create a JSON file. Well, the next step of an image is what's called layering. So what I want to do with, say I might create a base image that just has nothing more than bash and glibc inside of it. I want to put Apache on top of that. So I might want to create another layer. So what I could do is I could take my existing image, put it on disk, and then I'd install, say, Apache on it. And what I could do then is to create a difference between the original image and the secondary image and put that inside of a tarball. And then put another JSON file describing that this is no longer just the base image or run it with bash, but it has Apache in it. And then I could, say, put another layer on top of, say, a JBoss application on top of that. And then finally, I might write my actual individual application. So all of a sudden, images end up looking sort of like a wedding cake, in that you have multiple layers in your images. And so when I'm using when I'm pulling a image to my host, I might be pulling down multiple layers. Well, when I pull down those images or those layers, I need to store them on disk. So I need to basically use something on disk to put down each one of the layers. And the file systems that we use for that are called copy on write file systems. Really what we want to do is make sure that we keep each layer apart from each other, so we're only dealing with each individual layer. And then I could have, say, a write layer. So if I want to write on top of my image, I create a new layer and write to it. So that so we created a library, Go library, based off of basically Docker code. So when Red Hat first started dealing with Docker, we actually added a whole bunch of copy on write file systems to upstream Docker. So we decided to take all that code and build it into a library. And the goal was to have just a library where you're able to work on layering. So this is things like overlay file system, device mapper, Btrfs, all these different types of copy on write file systems. So now we have a way to store our images on disk after we pull them. And now we needed a way to run a container. Well, luckily the OCI did not only specify what the image format at disk is, they also specified what it means to run a container. And I'm going to talk a little bit in the next section about what happens when I want to run a container. But basically, when I run a container, it takes the JSON file that is upstream, so at the container image, and that sort of has the specification of what a developer wants to do when he wants to run a container, right? So if I, as a developer of the image, say, want to execute this application, I want these environmental variables, I might have special volumes, things like that in it, but basically that's the developer's input. The next person that is input into running a container is the container engine, the tool, Docker or a Podman, that has sort of hard-coded constants inside of it that sort of define what it means to run a container. And these constants, so when you pull down a container image and run it in your host, are things like what C groups is it going to be running into, what are the namespaces I'm going to use, what is the security attributes, SE Linux labels or drop capabilities. That's all sort of in the container engine. And then the last person that has input to running a container is the user, or in Kubernetes case, an orchestrator. And what that is sort of when you execute your Podman commands or your Docker commands, you're going to specify things like what volumes you want, or what what executable, maybe override the executable. So when you run a container, the container engine in the middle takes its hard-coded defaults, the stuff from the input from the developer of the container image and the user input, and combines all that together and writes out another JSON file onto disk. So that JSON file, now this is getting to this one, JSON file is very large, but it has all of the constants in it. It basically defines what the user and the engine and the developer decided they wanted to do when they wanted to run a container. And this is just a big, huge JSON file on disk. Finally, the engines launch a program. It's called an OCI runtime. And the OCI runtime reads the JSON file, interprets it, and actually instruments the Linux kernel. And finally, so basically it says, the next process I'm going to run, I want to run with these limited capabilities, these seccomp rules, these SE Linux labels, run them inside of these namespaces, inside of these C groups, and then it launches the first process inside of the container. So luckily that was standardized as well. So there became a OCI runtime specification, which happened about 2 years ago, or a year and a half ago now. And that basically defines the JSON file, the fields inside of the JSON file. We also created upstream, there's a project called Run C, and Run C is the default way that everybody runs containers. So almost every container engine in the world, including Podman, Docker, all execute the same program, Run C, which is the one that interprets the JSON file and instruments the Linux kernel to run the containers. So another thing, when I want to run a container, this is the last thing you need to do when you want to run a container, is you need to set up the networking. So you need to set up some kind of virtual private network that you're going to run your containers inside of. Again, CoreOS developed a standard for this, because the problem is that there was so many vendors that wanted to define how virtual private networks, like there's a lot of virtual private network companies, there's lots of open source projects that have defined what it means to be a virtual private network. And so we really didn't want to have just one way of running virtual private networks inside of containers. And what CoreOS did is they developed an API for that, and that's called the Container Networking Interface, CNI. And this is what Kubernetes uses for running all of its containers. This is used to configure it. So what people can do is it's sort of a plug-in interface for virtual private networks, so people can swap out different types of networks. We also have a tool that we added called Conmon, and Conmon is a tool for monitoring containers. When I launch a container, right, you can take the engine away. So Docker can disappear and Pod disappear, but the container can continue to run. But you need a tool that's going to monitor the container, watch what's happening on the container. The OCI runtime, that Run C tool, that actually just configures the kernels, executes the program, and disappears. So we had to develop a tool to sit up there and watch what's going on with the container. Now, if the container exits, it catches the exit status, or if you wanted to join back into the container. What we also want to do with Conmon is we actually wrote it in C because we wanted a very lightweight process that just sits out there and watches what's going on in the containers. So at this point, I usually talk about new big fat daemons. So what we wanted to do with all of our container tools, but especially Podman, was to basically get rid of the daemon. We didn't want to have a root running daemon for our containers. And we really wanted to, if all I'm doing is basically creating an OCI specification, executing Run C, why can't I just do that with a fork exec model? So why can't I just, pull down the image, put it into storage, mount the image, and then launch Run C, and do it all inside the same process space. And we wanted to look at how could we do multiple different tools, all interacting using the file system and the operating system to interact, and all be able to use the same images, same storage, but not have to rely on one centralized daemon to be able to run it. And then we could run containers potentially in different modes and with different properties. So when we looked at, again, going back to when I looked at Docker originally, my problem with Docker was that everybody in the world had to go through the Docker daemon. So if you wanted to launch processes on a Linux system, the only way that you were able to do that was Docker. And I wanted to invent new tools to be able to launch these Linux containers in my environment. So we built at that time three different tools on here, is really sort of splitting apart Docker into different types of tools for running them. So I'll go from the bottom up. So Builder is a container tool that basically does the equivalent to Docker build, but we wanted to experiment with different ways. So it supports Docker files, but we also wanted to experiment with building containers directly in Mesh and things like that. Scopio, I already talked about, is basically a mechanism for moving images around the environment. If the only way to move around your environment is to do a Docker pull and Docker push, if you're moving a image from an external registry to your internal registry, it seems kind of stupid to me to have to pull that image into root on your system, communicate with the root running process just to be able to then copy that tarball out of root out to another machine. So why not just have a tool that sort of does SCP or rsync type of tool, just basically take an image off of one web service and copied to another web server. And that's what Scopio is become. And then the last one is Podman, and that's one we're going to continue on. But Podman really was a way to sort of play with containers and really give you the Docker command line experience that most people wanted. We also built another tool, and all these tools, by the way, interact. They all work at the storage layer, containers, image, they all share all these, and that's called Cryo. And Cryo is a daemon launching, working with Kubernetes. So Kubernetes actually has to have a daemon that it talks to. So it basically calls out to a daemon over what's called a CRI, container runtime interface, and launches OCI images. So we built a small lightweight daemon called Cryo just to listen to Kubernetes. But basically, and what we can do with all these tools is we can actually make them specific to their task. So remember I talked about the container engine has sort of hard-coded standards for what it means to run a container inside of it. Well, we can actually have the standards differ per tool. So the Cryo can have tighter constraints. Podman does, and Builders just has the rules for building containers. And so we can actually sort of differentiate each tool inside of the engine. So let's look a little further at Podman. That's what we're here for. So Podman is a tool for managing pods and containers based on the Docker CLI. And so quickly, I just launched a few of the commands. Our goal when we first introduced Podman, if you follow the history of container technologies, CoreOS had a tool called Rocket. And what Rocket did is it basically had its own command line tools and containers, but they were different than Docker. Docker became popular. When we started up Podman, we said the #1 rule is that anybody in the future goes to Google and says, how do I do this with the container? They're going to get hit with the Docker command line. And we said we have to match that command line, your character for character. So the bugs we ever get from customers right now, users, tends to be, it works this way on Docker, but doesn't work this way on Podman. So we always have to say, okay, well, let's make it work in the same way Docker, or the command line has to work the same way, or the spec lines. And really what we want to do is make sure that we're actually totally work the same way that Docker does. So at this point, I think it'd be better to see a demonstration. Everybody see my terminal at this point? People see the terminal?
Yes.
Sure can.
Great. Okay. Okay, so this is basically a quick demo of Podman. This is all live. By the way, I have a newer version of Podman on my host, so hopefully I don't have the demo gods killing me here. But basically, if I just run Podman version, it looks very much like Docker version. Shows you a few commands, but a more interesting one is actually Podman info. And Podman info has a very similar interface to Docker info. Up here, you'll see sort of underneath the covers, we're actually using Builder. Remember, I talked about Builder is basically a way to do the equivalent of Docker build, but we wanted to break it apart, but we basically vendor parts of Builder into Podman every time to build. But here's a couple of interesting things. I talked about OCI runtimes. We actually also have an OCI runtime that is we talked about run C. There were other OCI runtimes available. We actually use C1 right now because we want to use cgroups v2, which Docker, even up to this point, still doesn't support. A couple other things to notice inside of Podman is that we support basically the concept of multiple registries. So Docker also had hard-coded into it that the only place to get containers was Docker IO. So everybody that's pulling down by short name, you would get it from Docker IO. What we wanted to do is allow people to use short name constructs from their own container registries. So if you had your own container registries, you'd be able to set them up and just pull it by the short name from them. You can block registries, you can change, you can remove Docker IO, you can do anything you want to configure the system the way you want. Lastly, so that's all part of containers image. And then container storage, which I talked about, is actually defined here. So you can see that by default, we're using overlay file system and But that gives you an idea. So one of the interesting things that we can do with Podman and is actually launch a container that actually builds a container in a container. So, so here what I'm going to do is I'm using Podman to run a container, and I'm going to pull down Alpine. So I'm building it based on that Docker file up there, and I just built a container inside of a container. Now people can do this with Docker, but in Docker world you have to do it with a by leaking the Docker socket into the containers. And that basically, in our opinion, opens up a huge security hole in the system. That's the way most people do it. But our goal here was to allow people to sort of take builds and actually distribute them inside of, say, a Kubernetes workflow or a huge workflow to run lots and lots of containers inside a container. And because we're breaking apart the Docker daemon into individual tasks, we can actually start to experiment, work with containers in different ways. So I just built that container inside of it, and now I'm going to show you. So there's the container inside of a container. So I built a container called my image here, and now what I'm going to do is I'm actually going to just remove all the containers. So that shows you, running containers, very similar to what you can do with Docker, a little bit more powerful. But if you noticed on those commands I was demonstrating, I was doing it all as root, right? I was executing sudo to root. Well, one of the really cool things, the thing that probably excites people about Podman the most is Podman can actually run fully rootless. So I can run it as a normal user inside of my system. So here I am running now, I'm not using sudo anymore, but in my home directory, I'm going out and I'm pulling down Alpine image onto the system. I just pulled it into my home directory. Now I'm going to launch a container. So I just ran the Alpine image, ran ls on top of the Alpine image. If I showed you, there's all the containers that I run inside of my home directory. So you can see a lot of containers. And then I can actually show you images. Again, very similar to what you can do with Docker. But as you can see, if I go back to sudo and do sudo podman images, I'm actually going to get a very different list, right? So there's the images I run as root and the images I run as non-root in my home directory are different, right? So each user, if you had 10 different users, say on a multi-user system, you could allow individual users to all run, the equivalent of Docker commands, but in their home directory without giving away root. Now, Docker has a way of doing this too, and the way Docker does that is they actually set up a Docker group, which allows any user on the system and that's in the Docker group to talk to the root running daemon. But that I wrote back in 2014 an article saying that is the most insecure thing you can do on a Linux system, because if I can talk to the Docker socket, I can basically create a container on your host and I can do evil things on your host and cover myself up. It's worse than giving sudo without password or giving out the root password on the system, in that you can just basically do anything you want and cover up the fact that it was you that did it. So let's examine how we're able to run rootless containers in using Podman. What Podman's taking advantage of is a thing called the user namespace. What user namespace does is allows us to, on modern Linux systems, any Linux system, actually as a RHEL 7.8, any Linux system as new or newer than RHEL 7.8 can actually take advantage of the user namespace. And what user namespace does is it creates a file in your system when you add a user. So if you just do a user add, your username, it will create a file, or it will populate a file on your system called etc sub-uid. There's another file called etc sub-gid, and inside of that, it's going to allocate UIDs, additional UIDs to be used by individual users. So my UID, I'm going to be showing you in a minute, is actually 3267, but it also allocates UID 100,000 and 65,000 UIDs are allocated to me. So starting at UID 100,000 up to 100,000, 655,035 UIDs are assigned to my account. So with the user namespace then, as a non-root user, I can actually just execute a podman unshare command. So I just became what looks like root inside of the system. If I just look at my home directory now, it looks like every file inside of my home directory is owned by root, which seems like a pretty dumb idea for a guy who claims to be a security guy to do. So if I go into the same directory and look, you'll see that actually all the files are owned by D. Walsh. So if I go back into, so what's going on here? What's going on is the Podman unshare, the Podman command put me into a user namespace. And if I look at the user namespace I can cast a proc self UID map. And that shows you sort of what the user namespace that I'm currently in. And what this does is it says UID 0 inside of my user namespace is actually UID 3267, my UID, my Dan Walsh's UID on the system. And I do it for a range of 1. And then Podman secondly sets up a user namespace starting at UID 1, starting at 100,000, and allocates my 65,000 UID. There's special tools on Linux that allow you to do this. There's nothing Podman, Podman's not setting a set UID program. These are all standard Linux tools that are available that allow you to do this. So now inside of this directory, I'm going to create, so right now I'm not in a container or anything else. I'm just in my home directory, and I'm going to do a make dir of test. Oh, I already created it. So I'm going to do a test of foo. Actually, let's do this. Make dir of test 1. And I'm going to do a touch of test 1 foo. And I'm going to do a chown bin :bin test 1. So if I look at test 1 now, you'll see I created a bin file. And so, right, just as if you looked at bin inside of the directory, I created basically a file that isn't owned by my UID in it. So if I go back into test 1 here and took a look at the directory outside of my user namespace, it'll show me the real UID. So basically Dan Walsh on the system created a process inside of the username, created a file inside of the user namespace that was owned by UID 100,000. And even if I go and try to remove the file now, I will get permission denied because I am not inside of the user namespace. So if I go back into the user namespace now, I can actually remove the file. Probably should have shown you.
How did you enter the user namespace?
Podman unshare.
Unshare, okay.
Oh, yeah, so just a simple Podman command. This is something that obviously you can't do in Docker, but it was something we wanted to, it's ended up being a tool that we use quite a bit, but pretty much every command I execute in Podman is actually sticking you into a user namespace and then executing the commands. So if you think about if I go to pull a image off of, say I pull down the Fedora image into my system, that Fedora image is going to come with multiple UIDs associated with it, right? It might have 15, 20 different UIDs in it. So if I'm putting that into my home directory, I need a way of being able to chown and create those files inside of my home directory. And so the user namespace is the key tool that's allowing me to do the magic. So let's take a little further look at the user namespace. So user namespace has actually been around for pretty much since Docker began, and absolutely nobody's ever used user namespace. The reason for this is manyfold. It's somewhat complicated to use, but the main reason is because file system support has never been there. But with Podman, we actually worked to improve container storage to be able to handle user namespace quickly. And so what I'm going to do right now is I'm going to launch a container. Okay, so I just launched a container, but up here you see that with the Podman command as root now, I said to use this user namespace to run the container. So this basically says I'm going to assign UID 0 inside of my container to be UID 100,000 on the host, and then I'm allocating 5,000 UIDs for the container. So if I go and look at using Podman, I can actually look at the processes on the system, and Podman actually kind of cool feature that allows you to look at individual processes. In this case, I'm asking it to show me the user inside of the container and what we call the host user. So this says that the sleep process on the inside of this container is running as root inside of the container, but actually it's running as UID 100,000 outside of the container. So now what I'm going to, and just to show you, here's the process running sleep on the system, just using standard PS commands. So now I'm going to launch a second container. on the system. And this time, instead of using the UID map of 100,000, I'm going to use a map of 200,000. So there's basically I'm launching a container with root inside of its containers being 200,000. So on the system. So the concept I want you to get here is we can actually use user namespace as an additional security mechanism, because if the first container got out, it was root inside of its container, but if it gets out onto the host operating system, it's going to be treated as UID 100,000. If I launched a second container as UID 200,000, then it would be subject to standard Unix permissions that a UID 100,000 process cannot interact with the UID 200,000, because again, you're inside the user namespace, you have root inside of your user namespace, but as long as the UIDs don't overlap between the containers, you actually are treated traditionally like a traditional processes. So as far as the Linux kernel is concerned, you cannot take advantage of any of the root powers that you have inside of your user namespace once you get out. So you're actually locked down. So you can imagine if you're running hundreds of containers on a system, if you could run each one of them in a separate user namespace, you get this additional security based on that. All right, another thing to look at, remember I talked about the big fat daemon. So one thing to understand between Podman and Docker is in Docker world, you're talking to the daemon, right? And the daemon actually is launching a container. You're not launching them locally. Podman uses what we call the fork exec model. Basically, it does a fork, and then the container ends up being a child process of Podman. So what I'm going to do here, I'm going to show you. I've asked hundreds of people around the world. Do they know what login UID is? And login UID has been in Linux for many, many years. And what login UID does is it records the UID that I logged into the system in. And once it's set, it can't be unset. So there's no process, even root, nobody's allowed to unset the login UID. This means if I go through su or sudo, become root, do anything on the Linux system, I can't basically, you can't cover up the fact that it was Dan Walsh that launched the process. Dan Walsh is the fact that these launched these processes. So here I'm going to actually run sudo. So I became root, then I executed Podman. Podman executes a container, and then the container cuts out the login UID, and you'll see here that it's still 3267 on the system. If I do the same thing with Docker and launch a container on the system, it comes out with a huge UID here, right? And this UID here is actually -1. So that's how Linux interprets -1. So every process on the system that is not launched by a user actually has basically -1, right? It's unset. It's the unset user. So because Docker is a client server operation, when the client talks to the daemon launches the container and becomes that. So again, let's look a little further why this is important. So I'm going to basically show a container breakout here. So what I'm going to do is I'm actually running Podman as root, and I'm doing a privileged container, and I can actually mount the entire slash, basically the slash of the entire operating system as /host, and then I'm going to modify etc shadow. What I did in this command here is I basically told the auditing subsystem to watch for people modifying etc shadow. Okay, so I modified etc shadow, and the auditing subsystem basically caught the fact that AUID Dan Walsh modified etc shadow, because again, it recorded it used login UID to figure out who was the process that launched. That Dan Walsh launched a process that modified etc shadow. So now I'm going to do the exact same thing, exact same command, but I'm using Docker this time, and to modify etc shadow, to touch etc shadow, and yet the auditing subsystem doesn't reflect that Dan Walsh launched the process, but it basically reflects the unset. It basically doesn't know who modified the container, modified etc shadow on the system. So the auditing subsystem has sort of been fooled and spoofed. And this is when I talk about, right now, there's no record that Dan Walsh did anything in the system except that I launched a container, right? So you could go to Docker and look at that container and say, oh, Dan Walsh did this. Well, the other thing I can do is I can destroy the container. And by default in Docker, if I destroy the container, it deletes the logs. So now you have no logging on your system that Dan Walsh ever did anything. So giving a user access to the Docker daemon, as I said, it's worse than su, it's worse than sudo. At least both of those programs would reflect that Dan Walsh modified the etc shadow file. But if I go through Docker, I don't have to do it. Okay, a couple other features. I'm going to show you up top. It's basically showing you sort of the namespaces that are available. And again, these are things that we didn't like about Docker. We wanted to, basically reveal some of this, what's going on in the system. So if you're in the PID namespace, you might, the first process looks like it's PID 1, but actually it's this is on the host PID. That's what its label is. If I want to see if it's SE Linux label associated with the container or the process inside the container, if I want to find out if seccomp, if I'm using seccomp for my containers, and I can actually even look at what capabilities, what is the Linux capabilities associated with my container. So what we're trying to do is reveal all this information so users can make smarter decisions about what's going on their systems. So last section I'm going to cover here is, so really I've been talking about containers all the time, but Podman also has a really cool feature in that it's called pod. So how do I deal with a pod, right? How do I deal with multiple containers inside of the same group of namespaces? And so with Podman, we've extended it to basically not only support containers like Docker does, but also support pods. And you can actually just create a pod here. I'll create it called pod test. Now I'm going to create a container associated with that pod, and I'm going to create a second container associated with that pod. So now I have a pod has 2 containers associated with it. I'm showing you that there's no containers running on my system. Now I'm going to start the pod, and basically there we have the 2 containers running. And if I stop the pod, it will show you that the containers are gone. So the basic idea is you can actually start to manage multiple containers all inside of the same group of namespaces in the same project from it. So that's actually the end of the demo. And let's, is there any questions at this point?
So questions, go ahead and unmute yourself to ask. Like I said, if you can't unmute yourself, then type them in the chat and I will repeat them.
Hey, yeah, I had a question. First, this was fantastic. This was amazing. I had no idea how powerful Podman was. While you were talking, it has now replaced Docker on my system. So you have 1 convert. The builder underneath, we build a lot of containers within our CI. Are you seeing people use builder to build their images before pushing them up to the registries?
Yeah, I mean, we're basically that's where builder is mainly being used at this point, is inside of CI/CD systems. What builder can do is, it supports standard Docker file and even inside of, for instance, inside of OpenShift now, we're using builder as a tool for, OpenShift 4.x basically doesn't use Docker at all anymore. So we use builder inside of, for building OCI images inside, if you've used OpenShift has the ability to build images as well as to run images inside of Kubernetes. So they're using it. Lots of other customers and users are using it. A lot of people experimenting with using builder inside of containers, inside of Kubernetes for running it. As I said, builder actually, just like Podman, also has full non-root capability. So you can run, you can do a Podman build, but you can also do builder low-level tools. So our original goal with builder my original goal was to allow people to experiment with new ways of building container images. I always tell people it's just a tarball with, it's a directory that put content in and stuff. And just from Bash, I could copy some files into a directory, tar it up, write the JSON file and move it out. So I wanted to build a tool that was able to do that. So that's sort of, we've been built into Ansible now. People are using Podman, our builder underneath covers for Ansible workloads. It's an OpenShift sourced image. Obviously it's in Podman for Podman builds. So people are starting to experiment. And that's really what the goal with builder was. So that gives you an idea. Any other questions?
Excellent. I also had, I have a couple of systems that are still running Docker Compose files. Is there a direct replacement similar to Podman?
That's in the rest of the presentation. So why don't we wait to get there?
Okay, perfect.
Anybody else? I can continue with the presentation. We can come back to questions. Just type them in if you want. So as of Red Hat Enterprise Linux 8, we dumped Docker altogether. We do not have any more support for Docker inside of Red Hat Enterprise Linux. If you want to use Docker in RHEL 8, you have to go to link to get it. And basically we wanted to replace, so Docker, inside the circle, you see Docker is not included in RHEL 8. For working with containers, use Podman, Build, Scopio, and runc tools to be able to run it. Also, as I mentioned earlier, OpenShift no longer uses Cryo and Podman for running containers inside of it, and then uses Builder internally to build container images. So one of the other things we wanted to do with Podman was to actually get proper integration with systemd. If you followed me at all, you know that I wrote heavily about the war between Docker and systemd back in the day. In fact, if you want to Google running a systemd inside of a container, you'll find the articles written by me. And it was always this tension that they didn't want to work well together. Well, we always thought that tension was kind of stupid. So we wanted to get proper integration between systemd and Podman. And the big war at that time was about running, whether or not you run systemd as PID1 inside of a container or just run sort of bash or whatever you want to run inside of a container. And I just thought both options should be available. So if you want to run a systemd based container on your system, using standard unit files and stuff like that, you just run Podman, run that container, and it'll just work. You don't have to do any special options or anything else. So we have proper integration there. We also support SD Notify. So for those that don't know what SD Notify is a way for a service. Say you're running a service inside of systemd. It's a way for you to tell systemd that you're ready to receive connections. And so it really was, if you run a database that takes 10 seconds to start up, you don't really want to start accepting connections until the machine is totally full, totally completely up. So a lot of people use systemd, but you can never use systemd SD Notify inside of containers, because if you put Docker client inside of your unit file, it actually does a client server operation. So there's no way to get that SD Notify back. Since Podman is a traditional fork exec, it actually works. Similarly, we have full support for socket activation. So a lot of our tools, a lot of people are now looking at socket activation. So imagine having socket activation where we're running a container image behind it, so that you don't want that service always running. So we have full support for socket activation. We've also we have these new commands inside of Podman. We wanted to look at ways people wanted to run containers. So a lot of people want to run a container as a service, right? So the machine boots up and it's running a container. Well, the problem is everybody that writes these services writes them differently. And so our constant bug report is, how do I do this inside of systemd? How do I get the unit file properly set up? So what we wanted to do is build a tool inside of Podman that would basically put the quote best practices into running containers. So we have Podman systemd generate. So you create your containers the way you want them, and then you can just execute the Podman systemd generate, and it will generate a unit file for running containers on the system, and run it both for containers and for pods. So if you want to run multiple containers on the system. We also wanted to look at Kubernetes support. So not that Podman is used for Kubernetes. What we wanted to do is make it easy to move back and forth between Kubernetes and sort of the traditional way people want to run containers. So in our vision, most people start out in containers, they play with Docker and they think it's really cool, and then they want to orchestrate, right? So running a single container with Podman and Docker is really cool. Running 2 or 3 is pretty easy. But once you get into the orchestrated world where you want the containers moving back and forth around the environment, you have to get to Kubernetes. And anybody that's ever tried to write code for Kubernetes, basically Kubernetes uses a YAML file, basically a fairly complex structure to identify what it runs a container. So what we wanted to do is basically design the containers you want, you get them running on your system, and then you do Podman generate kube, and we'll actually generate the kube YAML file. You can take that directly to OpenShift, directly to Kubernetes, and actually launch your containers inside of Kubernetes at that point. So we have Podman generate kube, so convert kube. We also have Podman play kube, so we can take a Kubernetes YAML and actually generate and use Podman to run traditional containers off of that. So there's Podman generate kube and Podman play kube. So similar to what we're doing with system D. We want to basically say you work out your workflow to run containers in your environment, and then you want to basically say, okay, these containers work well. How do I get them into Kubernetes? How do I get to the next step? And that's really what our goal there is. Or my Kubernetes container is now working well. Let me run it with Podman, and I'll use the traditional sort of what I understood with Docker or Podman workflow to go and play with the container. Once I'm happy, I can generate a new Kubernetes YAML file and put it back into Kubernetes. Anyways, that's what we're doing with Kubernetes. The next thing we needed is a way to talk to to Podman. So Podman's written in Go language, and again, it's just a fork exec model. The problem is that other people wanted to use other languages to generate Kubernetes. Things like Compose language or Docker PY. People were looking at, how do I remotely launch a container? How do I launch a container from Python on top of it? So originally, and actually this is current right now, we have an API that was based on a thing called Violink. This was a socket activated way of launching Podman containers. And so if you play with, there's actually a Podman remote command, and there's Mac and Windows clients now that will talk over SSH to a Linux box running Podman. We actually able to launch containers. We can launch Cockpit, which is a tool, a graphical tool on top of Linux operating systems to actually can launch containers, and that's actually Node.js talking to Podman to launch containers. So originally that was all written in Violink, and we had problems with Violink, so we decided to start to deprecate that and build a new tool to do it. I'll get to that in a minute. But anyways, there's Python bindings to be able to interact with Podman to be able to launch containers via Python. We also have remote support. I mentioned it quickly, but basically we wanted a mechanism so if you're on a Mac and a Windows box, you could talk to a Podman server running inside of a VM. So if anybody that's ever done boot to Docker and Docker machine, things like that, that's the Docker client sitting in Linux, sitting on Windows or a Mac, but it's talking to a VM that's actually launching the container. So we need that. Podman, we call it Podman Remote, just because that's the command when you run it on Linux, but on Mac and Windows, it's just the Podman command to do that. Those are all using Violink. I mentioned Cockpit support. So what I want to jump ahead to is we're just about to release our first semi-supported, it's sort of tech preview, what we call APIV2. And what this is this is the new API for Podman, for remote Podman, to replace the Violink interface. One of the problems with the Violink interface was that it wasn't compatible with the Docker API. So what we wanted to do is basically go back and look at it and said, well, most people that play with Podman think it's great, but if they have all these tools that were built on top of Docker PY or Docker Compose and other tools for launching containers that were talking to the Docker daemon. And so what we wanted to do is basically say, well, we could build a socket activated Podman command that will listen at run Podman sock, and anytime anybody connects, you can do an API that is very similar. I mean, basically, it is the Docker API for Docker commands, but if you want to do any of the advanced commands of Podman, those are also available to it. So so our goal with APIV2 is to support both. People want to run advanced commands using Podman, but if you have tools that traditionally talk directly to the Docker socket, they'll also be supported. So, and we've actually provided a tool called Podman Docker. It actually is an RPM package or a Debian package that you just install that, and that will set up all the links and everything else to make, allow you to execute your regular Docker commands or any command in the environment and interact with it. So really what we're getting towards is we, our own users, people developing this actually are using the Docker client to launch Podman containers. So, and our goal is to make this as, again, just like the CLI, we want to make it as API compatible as we possibly can. That being said, The question earlier was about Docker Compose. Docker Compose is actually isn't a Docker thing, right? It's a open source library, or it's an open source project on top of Docker. And the problem is it's huge. So we don't, at least my team, the developers that Red Hat is funding to work on Podman we don't intend to support Docker Compose. But we do have a fairly large community now that is basically creating a thing called Podman Compose. So bottom line is, one of the reasons we don't support Docker Compose, obviously, is because it's a lot of work. The second reason is we really believe in Kubernetes as sort of the way to run multiple containers in an environment. So we really wanted to concentrate on making the Kubernetes story, seamless to move back and forth between Kubernetes environments and Podman. There is an open source project called Podman Compose that's very active, and a lot of people are dealing with it. And now that we have Podman APIV2, we will, Docker Compose is actually just a language that is talking to the Docker socket. So if Podman can implement the Docker socket, then we would support Podman, Docker Compose talking to that socket, and anything that the socket API is wrong, we would fix those bugs, but we're not going to get into the deep level of the Docker Compose language. So that's how we're sort of dealing with Docker Compose. We've had some interest from users wanted to do Podman Generate Compose and Podman Play Compose, which because we're a fully open source effort, if some other group wants to do that, we would probably add support. But when it comes to RHEL, we probably put a big flag around it saying that not supported, or just use it at your own risk type of thing. Because again, we don't want to get into the massive amount of people who have written Compose scripts over the years, and we don't want to be supporting those. So that's our story around Compose. So a couple of things that we don't do and basically have no intention of doing with Podman. We don't support auto start right now. So auto start, if you've played with Docker daemon, because we don't have a daemon, we have nobody to automatically start a container. So you can basically create a container in Docker daemon. When the Docker daemon starts, it starts that container. We believe that's what systemd, right? Our daemon is systemd. We believe that if you want a container to start when the machine boots up, then you put it into a systemd unit file. So that's where we have systemd. We would tell you to use generate systemd and create a unit file and just use standard ways of doing systemd. We also don't support Docker Swarm. We believe that Kubernetes has won that battle, and that Swarm is at this point is dying off. So we have no intention of ever supporting Swarm. We don't support Notary, Docker Notary, although we do have a competing group. So if you want to do signing, we have a thing called simple signing. So Podman has a command called trust and has a command called sign that allows you to sign images and to set up trust that you only trust images that have these signatures. It's all GPG based. Notary is sort of was hot for a while, but most people don't use it. And there is an effort right now going on in the Kubernetes world to create Notary v2. If that happens, we'd probably look at supporting that. But again, even if someone in the open source community wanted to add Notary support to Podman, we'd accept the patches. It's not what we block. We also don't have full support for Docker volumes. We have file support. So if you played with Docker volumes, Docker volumes has a concept that people can build plugins for different kinds of volumes, and we just haven't got around to implementing that yet. And we have very little demand for it, so it's not been a high priority to implement it. But standard volumes, file volumes, unnamed volumes, all that stuff works. It's just that anybody that has an advanced volume doesn't work with Podman at this point. So what else are we working on? There is another full talk, and I will give Josh a link that he can get out to you so you can live that. There's some really good, cool talk that I did at DevConf this year, or at least I think it was cool, that talks about all the additional security features that we're trying to get into Podman. And a couple of the engineers who work for me did a talk, and there's a video of it that's linked here. And they talk about things like, how can we embed stuff into the image to make running a container So, basically, how can I run a container more securely? How can I generate seccomp rules for a specific container? How can I lock down and only run with the limited number of capabilities that need it? The talk is based on the Goldilocks and the three bears. And I say that most of container security right now is sort of at the Goldilocks, right? Not too hot, not too cold. And most of the talk is how can we get, what happens when containers don't work is people go all the way to mama bear. They turn off, they make the container as soft as possible. And what I want to do is how can we, without, how can I get closer to papa bear? How can I make this containers more secure, but not have the user have to do it? Because in my opinion, users only do one thing with containers. They either run them, or if they don't work, they turn off security. So what I want to do is how do I get a little more secure in my containers? There is a coloring book based on a lot of the technology that I'm talking about. And at this point, this is the final slide, and this is the real questions I answer. So if anybody has any other questions on this.
Okay. We're actually a little bit over time, and some people have had to sign off. Take one last question if somebody has one. Otherwise, we will sign off for the day. Okay. Well, thank you, Dan. This recording will be posted later. As soon as I figure out a place to put it, where everybody from Cloud Native Portland can access it. Still talking to the CNCF about video archives. If people have follow-up questions about Podman, et cetera, that they think of later, feel free to share those wherever. Good places. Podman has a mailing list. If you go to podman.io and look for the project. Also, people talk about Podman on the Cryo channel in the Kubernetes Slack. So let's see, question. Any links to the difference between Podman build and Scopio?
What was that again?
Any links to the difference between Podman build and Scopio?
Yeah, there's Builder. But yeah, there's some articles been written. If you just Google Podman and Builder, actually, if you Google differences between Podman and Builder, you'll find out that there was an article written on that years ago. But just like the Builder is basically being the equivalent to Docker build, and with some advanced features.
Cool. Okay. Well, thanks everybody, and watch the meetup and Twitter, et cetera, for the next one of these brown bags that we schedule.
Okay. Thanks for having me.
Thanks, Dan.
Bye now.
Thank you, guys.